If you've ever designed your own woodworking project, you may have had troubles trying to find the right scale and proportion of the elements that make that design look just right. In Greek times, they noticed that there was a common ratio in nature that made things appealing to the eye. That ratio is 1 to 1.618. This is oftentimes referred to as the golden section. But numbers really aren't important, it's the ratio that is. And to help with that, we came up with the Fibonacci gauge. This gauge always retains the ratio of 1 to 1.618, no matter how narrow or wide the gauge is spread. And let me show you how that works. That ratio can be seen here, from fingertip to knuckle and knuckle to knuckle. And as I expand the caliper, you can see it goes to the length of the finger, and that same ratio up to my wrist. Now let's look at it at the Parthenon. The width of the building, the full length versus the height, can also be broken down, the lower element to the roof element, and even farther, the height of the frieze as part of the roof element. Now let's look at a project that we designed recently to show how to find the location of this fixed shelf. Now let's design our own piece of furniture. Oftentimes, when designing a project, you must start with a critical dimension: the length, the width, or, in this example, our tabletop on this table will be 30 inches high. That is our critical dimension. To find its length, we set the ratio, the gauge, at 30 inches as a smaller portion of a ratio to find the width. 30 times 1.618 is approximately 48.5 inches. With that given length, we now want to find out where to place the legs. In this instance, we're going to set them at that 30 inches. Centering that 30 inches over the width gives us a location for the legs. Now we have the basic table form. To add a shelf and a drawer, we return our caliper down to 30 inches and use 30 times 0.618, and we get 18.5 inches. Let's center that over its height, and now we have the location of a shelf and the height of our drawer apron. We can also take that, in this example, and set our drawer width. Now let's add a couple things like the thickness of the elements. A 3/4 inch tabletop, maybe 1.5 inch wide legs, and our shelf. And there's a basic table. With the front elevation complete, let's draw the side view. To determine how deep our table is going to be, we can make a square table, we can make a rectangular table, and use any dimension and any proportion from those. Because we're using elements of the design to determine the depth, we keep things in proper proportion. For this table, it's a hall table. 12 inches is about as far as I want this table to project from the wall. To find a good 12-inch dimension, maybe start from the height, and we found that this was 18.5, leaving 11.5 inches. That will be a good close dimension to 12. So here is our table top. Now we need our legs. The distance between the legs can be found using the proportions right here. So there's our location of our distance between the legs. We have our 1.5 inch table legs that we designed earlier, so I'll draw those in. We'll transfer over our apron and the location of our shelf. After completing the elevations, I threw the dimensions on. I drew this on graph paper so it was easy to figure out what those were going to be. Don't be too precise at this point. Remember, we got to go out in the shop and build this project, so 1/8 inch and 1/4 inch dimensions, just round things off so it's easy to achieve. So now that you've seen how easy it is to design a project using the Fibonacci gauge, apply it in your shop, apply it in your designs. Good luck.